Alright, pre-calculus students, this is Miss Robinson again, and we are going to start example 1 together now. So example 1 asks us to determine which function is a polynomial function. So we're going to look at each function and determine whether it is a polynomial function. Then we should state the degree of the function if it is a polynomial function, and explain why if it is not a polynomial function. Okay. So before we begin, let's review our rules for determining whether we have a polynomial function. So if you remember, we essentially had 3 criteria. So the first 2 criteria dealt with the exponents of our function. So if we are looking at a function, in order for it to be a polynomial function, we must A, have all non-negative exponents or powers for our function. And then B, all of our exponents should also be whole integer numbers. Okay, so no fractions involved in our exponents. Our third criteria dealt with the coefficient of our functions. So the coefficients of our functions should also be real numbers. Okay, and that was all of our criteria. So let's go to look at example number 1. So if we look at example number 1, we have 5x squared plus 4x to the 4th power equals f of x. So let's start with our exponents here. So we have exponents of 2 and 4. Both 2 and 4 fit our criteria of being non-negative. Those 2 and 4 are both non-negative numbers. And they also fit our criteria of being whole numbers. Neither of those are fractions or decimals of any sort. They are integers. Okay. Our third criteria was that our coefficients be real numbers. If we look at this, our coefficients are 5 and 4. Those are both real numbers. So all 3 of our criteria are fit. We would say that this is a polynomial function. Okay. Our second step of this problem was that if we have a polynomial function, we should state the degree of this function. So remember, the degree of our function is the largest power or the largest exponent of our polynomial. So if we look here, we have 2 and 4. 4 would be our largest exponent. So we would say that this is a polynomial function of degree 4. Now moving on to look at B. So looking at B, let's go through our criteria. So we only have one x term in this function, this one right here, and the exponent for this x term is 1. So 1 is A, non-negative, and B, an integer, a whole number. So our exponent we do not have to worry about. Then we move into our third criteria, whether our coefficient is a real number. So we look at our coefficients here, -5 halves and 3. 3 and -5 halves are both real numbers. Though -5 halves is a fraction and it is negative, it is still a real number, it is not imaginary. So our third criteria is also fit. So we would say that this also is a polynomial function. Okay. And again, we need to find the degree of this function. So we look at our exponent. We only have one exponent, and this exponent is 1. So we would say that this is of degree 1. Now, degree 1, of course, means that this is just a linear function. So fairly straightforward. Let's move on to C. So C, we have f of x equals 2 minus 5 over x. So right now I can't really see the exponent of my x value because it is being divided. However, we know that we can rewrite this. We know that dividing by an x is the same as giving that x a negative exponent. So taking the reciprocal of this. So we can actually rewrite this as f of x equals 2 minus 5 times x to the negative first. Right? Okay. So we have this. Now looking at this different version of writing this function, I can see right away that doesn't fit my first criteria. I have a negative exponent. So we would say that this is not a polynomial function because we have a negative exponent or power for that function. So C is not a polynomial function. Okay. Moving on to D. D is very difficult to see as it is now because we have two different parts that are being multiplied to one another. Okay. We also have this square root going on. We know, however, knowing our exponent rules, that having the square root of an x, or anything for that matter, is the same as writing a fraction exponent. So we know that the square root of x is the same as x to the 1/2, 2 being the root in the square root, so it goes on the denominator. Okay, so we can write those square roots as 1/2 exponents. So we would end up having x to the 1/2 times x to the 1/2 minus 1. We can multiply these out to condense our function even more. And we would end up having x to the first, when we add those exponents, minus x to the 1/2. Now we can actually ask ourselves if this is a polynomial function. So we can go through our criteria. So our criteria, first, do we have any negative exponents? We look at our exponents, 1 and 1/2. No, neither of those are negative. Then we go to our next criteria. Do we have any non-integer exponents? 1 is an integer. However, 1/2, this degree here, is not an integer. That is a fraction, not a whole number. So here we discover that this is not a polynomial function. So we would say that this is not a polynomial function because we have a non-integer exponent or power. So if we sum up what example 1 told us, again, if we find that we have any x's being divided in our functions or any square roots in our functions, we automatically know that these cannot be polynomial functions. Okay? All right, to end off our video notes for tonight's assignment, or today's assignment, depending on when you're watching this, I'm going to give you a little joke. This has to do with polynomial functions, so I thought it was very fitting. Okay, so imagine we have two polynomial functions, an x squared function and an x cubed function, talking to one another. The x squared function asks the x cubed function if he believes in God. The x cubed function responds, well, I do believe in higher powers. Okay, I think that is very funny and very fitting for this situation. I hope you feel the same, and I hope you have a good night or day, depending on when you're watching this video. Thank you.